Hello, this is Rand Mohammad Abu Hammour, studying Communication Engineering from Princess Sumaya University for Technology. The topic I'm going to talk about is constant gain circles. Let's start with a small description of gain circles. We wish to describe the variation in GT with gamma S and gamma L in a graphical form. Let's assume that S11 is less than 1 and S22 is less than 1. GT refers to the gain. Gamma S and gamma L are the reflection coefficients. S11 and S22 refer to the input parameter and the output parameter respectively. Values of gamma S and gamma L that produce constant gain lie on circles in the gamma plane. Maximum gain occurs when gamma S equals the parameter S11 conjugate and gamma L equals the parameter S22 conjugate. These are points on gamma S and gamma L planes respectively. The centers of the circles lie on the line connecting these points with the origin. By necessity, 0 dB circle will always pass through origin, where gamma S equals 0 or gamma L equals 0. This comes about because GS equals 1 and GL equals 1 when gamma S equals 0 or gamma L equals 0. GS is the gain of the source. GL is the gain of the load. Now the question is, how to draw constant gain circles? Step 1. For input constant gain circles, we start by drawing a line from origin to the parameter S11 conjugate for gamma S plane. For output constant gain circles, we start by drawing a line from origin to the parameter S22 conjugate for gamma L plane. Now step 2. Determine the gain step of interest and the normalized gain factor. For input constant gain circles, we find out the gain of the source by applying the formula seen, and we find out the maximum gain of the source by applying also the formula seen, and then we find the normalized gain factor, which is G small s, which is equal to GS divided by the maximum GS. For output constant gain circles, we find out the gain of the load by applying the formula seen, and we find out the maximum gain of the load by applying the formula seen. Then we find out the normalized gain factor, which is G small l, which equals GL divided by GL maximum. Now for step 3, for input constant gain circles, we calculate DSS by applying the formula seen, and then for output constant gain circles, we calculate DLL by applying the formula seen also. For step 4, for input constant gain circles, calculate RSS by applying this formula, and for output constant gain circles, calculate RLL by applying the next formula. Now we have an example. The example says, draw input and output constant gain circles for 2, 1, 0 and -1 dB gain, if could, for a transistor with the following as parameters. S11 equals 0.707 for the angle -155, S12 equals 0 for the angle 0, S21 equals 5 for the angle 180, and S22 equals 0.51 for the angle -20. Now Let's solve this example. The solution starts by finding out the maximum gain of the source. And this is by applying the formula we had before. We find out that the maximum gain of the source equals 2 numerically, and then we find that the maximum gain of the source equals 3 dB. If we take a look, we find that 2, 1, 0, and minus 1 are less than the 3 dB, which means that we can draw constant gain circles for these 4 gains. Next, we find out the maximum gain of the load by applying the formula we had before. Numerically, the maximum gain of the load is 1.35. In dBs, it's 1.3 dB. This means that the gains 1, 0, and minus 1 are less than 1.3, and they are available. So we can draw constant gain circles for these 3 gains. Whereas 2, given in the example, is larger than the maximum gain of the load, which means that we cannot draw a constant gain circle for the 2 dB gain given in the example. Now, let's go to ketab. I will use ketab program, import the Smith chart. We click here on import from PDF, and I want this Smith chart. Okay. Zoom out a little bit. Okay. Now I will start solving the example. I will go back to the example and look at the first parameter, which is S11. It equals 0.707 for the angle minus 155. I'm going to take the conjugate of this parameter and start by the angle is minus 155. The conjugate for it is 155. So I go to ketab, I take the pen, zoom in, I mark the angle of 155, which is nearly here. Here is a mark. This is 150 and this is 160. I want 155. Then my direction is the ruler. I take the ruler and from the origin I want to draw the line. I will try to be as much as I can accurate. Here's a line connecting the origin. I will use the pen. A line connecting the origin with the angle 155. No need for the ruler now. X. Okay. Next, I open. I see that the magnitude is 0.707. So I go to ketab, to the Smith chart. I take the compass. Here it is. I don't want the pencil of it. And my direction is the reflection coefficient scale. Okay, it is 0.07, which means 0.707. Yes, 0.707, which means approximately 0.71. Okay, this is 0.71, and here it is. Now I go back to the line I drew. I put here on the center as seen. Okay. Now I want the pencil. Now for the pencil, I want to make sure that there is no color inside the circle I'm going to draw. I don't need to draw a circle, actually. I just want to mark this point. I take the pen again. This point, the intersection of these two lines, is the point with the maximum gain. So I can write here, say 3 dB point. Smaller, smaller, smaller. Okay, done. This is the 3 dB point. Okay, now to draw the circles for the 2, 1, 0 and -1 given in the example, I go to the calculator. This calculator can easily give us the radius and the distance for the circle I'm going to draw. I don't want ketab, I'm sorry. I need this, okay, and I need calculator. This is a very easy calculator to use. I just put here the values of the parameters as seen. Okay, 0, 0. Here is 5, 180, and 0.51 minus 20. Okay, I filled the blocks. Now I take a look. I see that the constant gain circles are in here. I click here. I don't need the plane. Okay, now here is the constant gain circles. Now the gain at the source, I want 2, so I put 2. I click on constant gain circles. We find out that the radius is 0.254 and the magnitude is 0.625. These are the radius and the distance of the circle of the 2 dB gain that I will draw on the same phase line I drew before, which is 155. Now I need 1. We have the same radius and magnitude. For the 0, yes, and for -1. Now, to make this easy, what I've done actually, I put them in a table. for the 1, for the 0, and for the negative 1. Also for the 2, I can do it as well. For the output gain circle, I go also to the calculator and fill in this. I put 1, I put 0, and negative 1 as well. I have here the radius and the magnitude. Okay, now the tables are in front of me. I will go to the input gain circles of the input. Let's go to ketab. Now here, for the 1 input gain circle, I want the distance. The distance is 0.546. I take the compass. Okay, I don't need the pencil. I take the compass to the reflection coefficient scale. Here. Okay, I don't need you. I go back. It's 0.546, which is 0.55, let's say. This is 2, this is 4, here's 5, which is this approximately. Okay. What I will do, that I will go back here and put it at the center. I don't need the pencil right now. This is not the center. I want to be accurate and selecting this. Okay, this is fine. Now I need the pencil to mark the point. Okay. I go back here, I find that the radius is 0.374. So I go back to ketab, take the compass, back to the reflection coefficient scale. Okay, how much is it? It's 0.37. 0.37, which means this is 0.34, 0.36, 0.37. This is it. Okay, here is it. Now I go to the point I marked here. And I draw the first constant gain circle. Oh my god. Okay, this is the 1 dB. For the 0 dB, I repeat the same steps. Okay, I open here. We find that the distance is 0.471. 0.471. This is 6. Here is 7. Okay. On the reflection coefficient scale. I go back here to the center. I select it accurately. Now I need the pencil. Go right here. I look back. I find that the radius is the same. So here is the center. And I draw the next dB circle. Here it is. I put here. This is 2 dB. Okay. Now for the circle of the -1 dB, I go right here. It's 0.402, which means approximately 0.4. Like this, and I go to mark the center of the gain circle. I put it in the origin, go right here. It's not at the origin. Put it well, okay, and then here I need the pencil. Okay, now I go back to the reflection coefficient scale. And look, we find that the radius is 0.556, which means 0.55. Let's say this is 0.55. Okay, this is good. Now, like this, I go back, and from the center I marked. Now I need the pencil. I draw I'm sorry, this is the 0 dB circle. Okay, and the last one is the -1 dB. No, not this. This, and I put it right here, larger. Okay, I can write here, add input constant gain circles. Make it smaller to make it appear. And these are. I didn't take the 2 dB. I put in the calculator 2 constant gain. I find that the magnitude is 0.625. So I take this to 0.625. Here it is, and here's this. Now I go back and do the same step. It's not put well in the origin. Okay, here. I mark, and then I go back to the reflection coefficient scale. To find out, sorry, I want this. The calculator says that the radius is 0.254. 0.25. This is 2, 4, and here is 5, 4. Okay. No pencil needed. What I need is this. I go back. This is the center I want. And I draw the circle. And write 2 dB. We find out that when the gain is smaller, the constant gain circle is larger. Now, these are the constant gain circles for the input. We repeat the same steps for the constant gain circles at the load. So, I go back right here and put 1, 0, and -1. Why we didn't put 2? Because the maximum gain is 1.3 and 2 is larger than the maximum gain. So if we apply it also on the calculator, if we put 2 here, we find that radius is 0. So there is no circle found. Now, to draw the circles at the output, first of all, I come back to the example. I see the parameter that S22 equals 0.51 for an angle of -20. I take the conjugate of this parameter and I go to ketab. The conjugate means that the angle is 20, not -20. I go to ketab. No need for the compass right now. Zoom out a little bit. Okay. I need the pen. Where is the pen? I want the angle of 20, which is this. I mark the angle. Now I go to tools. I take the ruler and same from the origin. Here it is. Okay. To the angle of 20. It is at the origin. Okay. I take the pen another time and draw a line intersecting the origin. Oh, what happened? Edit. Undo. Okay. I don't need the ruler anymore. We will repeat the same steps, but for the output constant gain circles. So, I go back here and I see that I want to mark the 1.3 dB gain, which is at the distance of 0.51. So I go back to ketab. I choose tools. I want the compass. Here it is. and at the reflection coefficient scale I want what? 0.51, which is approximately 0.5 here and here. I take the compass another time, but now for the gain of the output or the load. I need the pen, I don't need it right now. Here, okay, here's the pencil, and here is the point. Now I take a pen and mark it. And here is the 1.3 dB point. Okay, here, this is fine. I go back to the table I designed from the calculator, and the distance is, for the 1 dB, it is 0.484. So, I go to ketab, to the reflection coefficient. Things are becoming easy now, because it's all repeated. No pencil needed. 0.484, 0.48, it is here. Here, I want to remark the center of the 1 dB circle. So I go at the origin, here, I mark the origin of, I mark the center of the origin of the circle I'm going to draw. Back to the reflection coefficient scale, the radius is 0.19, which is approximately 0.2, I can say, here. Okay. I go back. This is the center, and I draw the circle. This is the 1 dB. I return back to the reflection coefficient scale and go to draw the gain circle of the 0 dB. We find that the distance is 0.405. Oh, I'm sorry. 0.405, which is approximately 0.4. This is the center of this circle. I go to the origin and remark the center of the circle. The radius of this circle is the same, so I draw it. Now I write here, 0 dB. And for the last circle I'm going to draw, I go to the reflection coefficient scale, but first the distance is 0.336, okay, 0.336, here is 2, here is 8, okay, this is fine enough. And from the origin mark it. No pencils needed. I go back to the reflection coefficient scale to determine 0.53. 0.53. Here is 2, here is 3, in between. Okay. Here it is. Now, from this circle, this is the center. I want the pencil. And this is the -1 dB circle. Okay. Another block to write in. I will write output constant gain circles. What's happening here? Oh. Now, no need for this. By this, if I make it zoom out, I find that this is the shape I got after solving the example. At the left, we find the input constant gain circles, and at the right, we find the output constant gain circles. It's easy enough, and we can do it easily. Thank you so much for watching. I hope this was good enough to understand. Thank you so much from me, Rand Mohammad Abu Hammour. Thank you.